Hello again, students. Welcome to another lecture video of mine. Today we're going to learn about radioactive decay in 15 minutes. Just a quick note, this is in Matriculation Physics Semester 2, Topic 11, which is Nuclear and Particle Physics. I would like to start the lecture by asking, what happens if a nucleus of an element becomes unstable? Let's say that you are that particular nucleus. What would you want to do if you suddenly become unstable? Obviously, you would want to be or feel stable back, right? Let's see what an unstable nucleus would do to be stable again. So, what can you deduce from the GIF that I just shown? You can see that it removes a part of itself. What is the part that is being emitted? What do we call it? And what is this phenomenon called? This is what we call radioactive decay, which we will learn about today. So this is the learning outcomes for today. So we only have one learning outcome. So by the end of this video lecture, after watching this video, you should be able to explain alpha, beta plus, beta minus, and gamma decays. So although it's just one learning outcome, you will learn a lot about it in terms of the radioactive decay characteristics, each of the decay equation, as well as what happens when we put it inside like a magnetic or electric field. Let's just do a brief recap from previous lectures. So for this topic, topic 11, which is nuclear and particle physics, we learned that there are four types of nuclear reaction, where earlier we learned about nuclear fission, which is about when a heavy nucleus splits into two lighter nuclei that are almost equal in mass with the emission of neutrons and energy, and also about nuclear fusion, where two light nuclei fuse to form a heavier nucleus with the release of large amount of energy. This time, we will take a look at radioactive decay and understand what it is, its characteristics, as well as the radioactive radiations that are emitted when an unstable nucleus decays. Before we can understand radioactive decay, we must understand what radioactivity really is. So, as you can see here, radioactivity is basically the spontaneous disintegration of certain nuclei accompanied by the emission of alpha particles, beta particles, or gamma radiation. It has a different definition than radioactive decay, which is the phenomenon in which an unstable nucleus disintegrates to acquire a more stable nucleus without absorbing an external energy, which we can see happen in our GIF earlier. The nuclei is unstable in the first place because it is so heavy that it's so difficult to hold it together. So the amount of force is really high to hold it together closely. So it either have too many protons or too many neutrons. That is why it undergoes radioactive decay to achieve stability. The main characteristics of a radioactive decay is, firstly, it is spontaneous or unplanned, kind of like when it magically rained on a hot day, even though you couldn't see like the earliest sign that it will rain that day. The next one is that it cannot be predicted and is independent of physical conditions such as pressure or temperature and chemical changes. This is kind of like we don't know what the future holds. Lastly, it is a random reaction because the probability of a nucleus decaying at a given instant is the same for all the nuclei in the sample. This is kind of like when you throw a dice and the probability of hitting one of the numbers are the same for every number. Now we will move on to the three types of radioactive radiations. We first have the alpha decay. So it looks like this. This is an alpha, by the way. It's a symbol of alpha. Then we have the beta decay, which can be categorized into two types, which is the beta plus decay. So we add just the plus on top as a superscript, and the beta minus decay. So we add a minus on top. Lastly, we have the gamma decay. The main differences is that alpha and beta is a particle decay. It involves the alpha and beta particle, while the gamma decay is just involve a gamma ray. We will start with alpha decay, where we first learn about what is an alpha particle. It is a helium that is consisted of two protons and two neutrons. What do we mean by that? Let's draw a symbol of it. So we have a helium over here, and since it has two protons and two neutrons, the upper part of it, which represents the mass number, is the sum of both, so it will be 4 because 2 plus 2. And the bottom left of the chemical notation, which represents the atomic number or the number of protons, would be 2. It would look something like this. The alpha decay equation looks like this. The parent nucleus, which is unstable, undergoes an alpha decay, and the end product would be a daughter nucleus and an alpha particle. The daughter nucleus is a new element which must have the parent nucleus mass number minus 4 and the parent nucleus's atomic number minus 2 in order to make the equation to be balanced, because He4 or helium-4 was emitted. In turns, there will be a stable daughter nucleus. So this is what I mentioned, but it's much more simpler, which is an unstable nucleus releases an alpha particle to become a more stable nucleus of a new element. We will now move on to beta decay. Now, a beta particle is a fast-moving electron or positron. Since there are two types of beta decay, we will see what is decomposed in each of the types. During a beta minus decay, a neutron of an unstable nucleus decomposes into one proton and one electron. The resulting proton remains in the nucleus, while the electron is emitted with high kinetic energy as a beta minus particle. Meanwhile, in a beta plus decay, a proton of an unstable nucleus decomposes into one neutron and one positron. So the resulting neutron remains in the nucleus, while in this case the positron is emitted with high kinetic energy as a beta plus particle. After seeing the decomposition of neutron and proton, we will know more about the beta minus decay, or otherwise known as electron emission. This decay happens when a nucleus has too many neutrons, and as in the previous slide, the beta minus particle is an electron. This is how we write electron in a symbolic notation. So we just write the letter E, with the minus sign on the superscript. In front of you is the beta minus equation, where from the unstable parent nucleus it will decay into an electron, which is negatively charged, and a stable daughter nucleus, which is a completely new element. Since an electron was removed, to balance the equation, the atomic number of the daughter nucleus would be the parent nucleus's atomic number plus 1. So this is the description of what beta minus decay really is. The beta plus decay, or positron emission, on the other hand, happens when a nucleus has too many protons. Therefore, when a nucleus decays, it emits a beta plus particle, which is a positron. A positron is symbolized with the electron symbol, except for this time, instead of a negative, we use a positive as the superscript. This is because a positron is positively charged. The equation of the beta plus decay is quite similar to its counterpart, except since the positron is positively charged, the atomic number of the daughter nucleus would use the parent nucleus's atomic number minus 1 to balance out the overall equation. This is what I mean. So it will be minus 1. This is the description, which is an unstable nucleus releases a beta plus particle to become a more stable nucleus of a new element. What about gamma decay? Gamma decay happens when a nucleus has too much energy. To get rid of this excess energy, gamma rays are emitted. These gamma rays have no mass and are neutral. One may represent gamma rays as itself, which is just the Greek letter gamma. The gamma decay equation looks like the following. The parent and daughter nucleus is the same element because there are no changes in the mass number or the atomic number of the element, as the gamma rays that are released have no mass and are neutral. Therefore, the end product is just the parent nucleus itself, which is now more stable, and the gamma rays. So, and this is the description for what gamma decay is. Exposure to very high levels of radiation, such as being close to an atomic blast, is very dangerous to us. It can cause acute health effects such as skin burns and acute radiation syndrome, which is also known as radiation sickness. It can also result in long-term health effects such as cancer and cardiovascular disease. It is important for us to know how we can protect ourselves from radiation to prevent ourselves from getting these harmful effects. We can equip ourselves with the knowledge of radiation shielding, which is described as an interaction between particles and matter through collisions and capture by atoms. Here we can see the three types of radiation that we learned just now. For alpha particle, paper or skin is sufficient enough to protect ourselves, but obviously, if the amount of alpha radiation is a lot, it is still dangerous. For beta particles, aluminum can be used to shield ourselves, while for gamma rays, lead is used because it is difficult for the gamma rays to pass through, so it is an excellent shield to use to protect ourselves from radiation, obviously. The effectiveness of shielding is dependent on stopping power, which varies with the type and energy of radiation and the shielding material used. Different shielding techniques are therefore used depending on the application and the type and energy of the radiation. Shielding reduces the intensity of radiation, increasing with thickness. In summary, basically, high atomic number and high density materials such as lead, tungsten, and concrete provide the best effective shielding against all these radiations, and especially gamma ray radiation. What if we put these three types of radiation into an electric field? What would happen? Let's analyze it together. So, we know alpha particle is just the helium-4, right? So we know that it is positively charged, therefore it would deflect in towards the negatively charged plate, because positive attracts negative, so it would look something like oop, over here. Beta particle, on the other hand, where we will use beta minus particle, is an electron. So we know that electron is negatively charged, therefore it will deflect towards the positively charged plate. So it looks something like this. Sorry. Something like this. So, similar case, well, negative would get attracted to positive. Take note of the distance or range of the deflection. An alpha particle would get deflected further away as it has two protons compared to the beta particle, which is an electron that which has just one negative charge. So what about the gamma ray? We know that it is massless and neutral, therefore it would not get deflected into any of the charged plates, so it will go into the straight line. We have reached the final part of the lecture, which is the summary. So, firstly, what we learned today is about radioactive decay. So we know the definition of it, and then we take a look on the characteristics of it. Then we know that in radioactive decay there are three types of radiations, which is, well, beta plus and beta minus is technically beta decay. So there are three types, so which are alpha decay, beta decay, and gamma decay. Each has an equation of its own particles or rays, and has differing strength. Lastly, in an electric field, alpha particle will be deflected towards the negatively charged plate, beta particle will be deflected towards the positively charged plate, while the gamma rays will not get deflected into any of the charged plates or travel in a straight. So I have prepared you guys with the take-home exercise which you will do on your own. So it is related to the radiations being placed in a magnetic field instead of an electric field that we just see just now. So that's it. Bye. Thank you.